Okay, thank you. Hello, everyone. It is my great honor to be here to share one of my studies today. My name is Dengfeng Xu, come from the Department of Nutrition and Food Hygiene, Southeast University, China. Today, my topic is serum metabolomics, reveals underlying mechanism of cholesterol lowering effects of alt consumption, a random control trial in a minor hypercholesterolemia population. I will introduce my topic from the following five parts. The first part is the background. As we all know, dyslipidemia usually refers to the elevated serum cholesterol and or TG levels. In fact, it also refers to various dyslipidemia, including low HDL-C. Dyslipidemia is generally divided into the following four characteristics in clinical, which are high TC, high TG, both high TC and TG, and also low HDL-C. The prevalence of dyslipidemia in China is serious recently. The figure shows that the trend of dyslipidemia in Chinese adults from 2002 to 2021. We can see an obvious increase in total prevalence from 18.6% to 45.4%, also seen in countryside and the city, as well as male and female. So dyslipidemia is an important risk factor for many diseases such as stroke, diabetes, and obesity. It is also a key contributor to the CVDs. According to the report of WHO, there are 18 million persons die from CVDs and make it the leading cause all around the world. So it is very necessary to find an alternative way to improve this situation without any side effects. However, oats is a whole grain with a lot of biological effects. For example, it is reported that oats could decrease serum TC and LDL-C level, control fasting glucose, decrease weight and blood pressure, and further mechanisms had been explored and accepted by others, such as metabolites of short-chain fatty acids and induced gut microbiota. However, the underlying mechanism reflected on serum metabolomics reform under investigation. So, we performed this random control trial with the primary outcomes of exploring the effects of alt consumption on serum lipids profiles in a population with minor hypercholesterolemia. The second outcome is to observe the changes on serum metabolites and find the relationship between the lipids and the metabolites. So the next part is the methods. These random controlled trials involved 62% participants with minor hypercholesterolemia. Qualified participants were randomly assigned to the test group or the control group. Subjects in each group were required to consume a total of 80 grams per day of the intestinal test samples while maintaining their dietary habits. At the day 0, day 30, and day 45, we collected the blood samples and some other necessary data respectively. So the inclusion and exclusion criteria are as follows. Briefly speaking, we refer to the Chinese guidelines on prevention and the treatment of dyslipidemia in adults, the version revised in 2016. The definition of the minor hypercholesterolemia is referred to TC level between 5.18 and 6.21. In addition, TG level should be less than 2.25. Some other exclusion criteria include pregnancy or lactation or poor compliance. So the most important samples is blood samples. With this sample, on the one hand, we selected the serum lipid profile with the automatic blood biochemical analyzer. On the other hand, we explore the serum on-target metabolomics with the UHPLC QE mass platform. Also, we want to find the relationship between them. So the next part is the result. Table 1 shows the nutrition composition of the two test products. Of note, we can see a significant difference in beta-glucan and polyphenol, which may be the functional composition in present trials. And the figure 1 presents the flowchart of this trial. Also, the table 2 shows the baseline characteristics of the participants. Since all the p-value is more than 0.05, there was no difference in ages or generally clinical parameters between groups. So, after 45-day intervention, the p-value for interaction in TC, LDL-C and the non-HDL-C are all less than 0.05, indicating a significant difference between groups. So, compared with the baseline, out group had a reduction by 8.41 for TC, 12.93 for LDL-C, 10.73 for non-HDL-C, which are more obvious than that in control group. All those results suggested an improved effect of OAT in serum lipids profiles. Then, let's see the effects on serum on-target metabolomics after 45-day OAT consumption. Because the high-quality data are prerequisite for metabolomics analysis, so PCA score plots of the sample QC for both positive and negative model were constructed. Variation in all samples were in the range of 2 times of SD. These results indicate that the HPLC QE mass system operates with a high stability. So, after the detection, a total of 5,696 peaks were detected, of which 505 metabolites were identified according to the MS2 database in position model. On the other hand, in negative model, the data are 4,326, 253 respectively. Most of them belong to the subclass of lipids and lipids like molecules, original ads, and others. So first, and to obtain an overview of the serum metabolics results, we performed a PCA analysis to determine the between groups difference in metabolites after the investigation. However, the distribution of serum samples in PCA score plots didn't indicate a separation between groups. In this way, subsequently, a supervised OPLSDA analysis was performed and found an obvious separation. Also, the two times permutation test found that there was no overfitting for the OPLSDA. All the results indicate that the reliability of the data. Further, based on the threshold of VIP value of OPLSDM more than 1 and the p-value less than 0.05 of the student t-test, a significantly different metabolomics profile was screened. That is table 4, a total of 21 significant metabolites, including this one and these four. These four metabolics which are regarded to be very important in the improvement of lipids. So to further understand whether the obvious change in serum metabolics upon outer consumption reflect changes in metabolic pathways, we use the metabolic analyzer for short while to examine the relative pathways. Bible reports reveal that the four potential metabolic pathways identified upon out-consumption, which are classic lipid metabolism, alanine aspartate and glutamate metabolism, and sphingolipid metabolism, and retinol metabolism. These four pathways may be largely impacted by out intake. Finally, we use Spearman correlation to further examine correlations between serum metabolomics and clinical parameters in both out and rise groups. As shown in Figure 6, there was significantly positive correlation between the serum level of TC, non-HDL-C, and LDL-C. Also, with the serum metabolites including the single-link PC and the retinol acid. So also there are some limitations. So first one is the frequency of exercise for participants was not recorded in detail. We only conduct a brief questionnaire to check if they had changed their lifestyle in body activities. The lack of an accurate record of exercise might create some bias in our result. The second is that even though the sample size was sufficient to evaluate the effect of odds, 31 patients in each group are still a relative small number. The last one is that we observed a mild improvement in serum lipids in control group, which may indicate that the dietary changes among the control groups. Will dietary changes lead to the shift in serum metabolites need to be further studies. So the last part is the conclusion. Finally, we concluded that the outer consumption had beneficial effects on serum lipids profiles, and the underlying mechanism involved the four pathways. So and the last all the above that I want to share today. I'm very appreciated for your attention. Thank you.